All right, this is worksheet 3, problem 6. A 10-gram piece of metal, okay, so from that, I know already that that's its M for mass, okay? Piece of metal with a specific heat, okay, so it even tells me my specific heat, that's C. At 55 degrees, okay, so that's AT, is warmed up by an addition of 655 joules of energy. So this is my T1 because that's my initial, okay? And I know that this is Q. So it says find the final temperature of the metal. Now, my first question, is this water? It is not water, so all you're going to be worried about is if it's heating up or cooling down, and you're just going to be doing a positive slope line or a negative slope line depending on the direction. You're not going to have to worry about any phase changes because we're not mentioning any of those phase changes. So you're just going to assume that it just gets hotter or colder. In this case, I know we're starting at 55, so I'm going to mark 55, and then I added energy. So, and it says it's warmed. So I know I'm going to go up to a certain temperature. That's actually what I'm trying to find, which is my TF, my final. Okay, so now what I'm going to do is I know that this formula, because it's a positive slope line, is Q equals MC delta T. I also know that it is endothermic because it is going up, so it is absorbing more energy. All right, so my Q in this case is 655 joules. Okay, my M in this case is 10 grams. My C is 0.600 joules per gram degree Celsius. And my delta T is final, which is my I don't know, minus my initial, which is 55 degrees Celsius. All right, with this one, it's really important that you start consolidating all your stuff because otherwise it's going to be very, very confusing. So we get 655, and I'm going to do 10 times 0.6, get rid of my units. So it's going to be 6. Okay, so 10 times 0.6 is 6, and then that is times x minus 55. Take your time, okay, and distribute. So I've got 655 equals 6x, and then it's going to be 6 times 55. You could have divided by 6 also if you would like to do that way. That's totally fine. And then that's minus 330. You will end up getting the same answer. So now I'm going to add 330 to both sides. So it's 655 plus 330. Which is 985. So I have 985 equals 6x. Now I'm going to divide 985 by 6, and I get 985, so x equals 164.2 degrees Celsius. All right, so that's my final temperature that it was able to get up to. So now let's look at sig figs. 10 with a decimal has 2. This guy, the specific heat, has 3. This has 2, and this has 3. So my lowest number is 2, so I'm going to round to 2 sig figs. So that's 1, 2. That number, that 6, will stay the same because the one after it is a 4, so it's going to be 1, 6. That 4, because it's a decimal, will turn to a 0, and that 0.2 will fall off. So it's 160 degrees Celsius is the final temperature of this metal.